Hello friends, welcome to this channel. Here let's look at a newly appeared problem, longest palindrome after substring concatenation. This is the second of a series of problems. The previous one is problem 3503. Therefore, our code here will solve both the two problems. In fact, this problem here is a larger size version of problem 3503. The method will be dynamic programming, but in order to solve this problem, you need to have some prerequisite, otherwise it will be slightly harder, right? So it would be good if you know how to find the longest palindromic substring of a given string, right? So if you know this, then build on that problem, you can solve the current problem or design a solution of for the current problem using dynamic programming. Our plan will be the following. So first, I'm going to write a hyperfunction doing the following thing. Basically, for a given string, and we can find the longest palindromic substring starting at each index towards the right? And then we're going to write a DP solution using the hyperfunction. So this will be our plan. Now let's quickly look at the problem statement. So here, basically, we are given two strings, S and T. So we want to create a new string by selecting a substring from S and a substring from T. It can be allowed empty, right? And also we are considering substring. And then we concatenate them in order. So here the order is important. So we first we concatenate S and then with T. By concatenate we mean concatenate the selected substrings respectively, right? So we want to return the length of the longest palindrome that can be formed this way. So in example 1, so you get 2, right? You can concatenate the two A's. For example 2, because these two strings have length 6 together, and there are 6 unique letters, right? So you just have 1. So for this one, you return 4. That actually is T, right? For this, this is the generic one. You can choose ABC here, and then you can choose CBA, ABC from S, and BA from T, right? You get 5. So the length bound is bounded above by 1000. The second is just some consistent one, right? So with that said, I guess we can first do this one. Write a hyperfunction. Basically, given a string, I want to find the longest palindromic substring starting from each index. So this is actually the hint 2 and hint 3. Essentially, hint 2 and hint 3 are the same, but hint 2 is given the index that you want to move towards the right and then find the longest palindromic substring starting at index I. And for hint 3, it's ending at index I, and because you want to move towards the left. But essentially, it's the same thing. You need to be able to find the longest palindromic substring of a given string, right? So here, let me write a pass. First, I'm going to write the hyperfunction. So I'm going to call it just hyper, right? Self. I'm going to write it as a method. So basically, first let's get the length of this in, right? And then I'm going to initialize a DP. So 0 times in for a dummy index in range m. So basically, the interpretation will be the following: dpij. So if so S starting from index I and ending at index j, both inclusive, is a palindrome. So here, how do we do this? We know when I equals j, right? And then so the length it is a palindrome, but the length is 1. And if I minus j have difference 1, in other words, j is I plus 1. So we just need to compare if the two characters are the same. But for the larger differences, we need to use a general update rule. So here d, because the largest I and smallest I will be 0, the largest j will be n minus 1. So d is actually can be 0, can be 1, can be n minus 1. So in other words, the range of d is for d in range n, right? And then let's do I. For I in range, so I can write start from 0 and then actually ending before n minus d. So you can think of this: if d equals 0, so the I should ending at n minus 1, right? Because d is 0, you write n here, right? So it verifies that using the special case verifying the general case, or interpret, or just a sanity check. So now let's look at the case. If d equals 0, so we know dp I plus d, and this is basically dp ri, so we should send it as 1, because single character, right? Otherwise, let's see, if d equals 1, so in this case we just need to consider if si equals si plus d, right? So I plus d will be j, right? So here you can interpret j minus I equals d, right? So if this is the case, so dp I plus d will be 1. Actually, you can write an else and set this to be 0. So this is logically more clear, but it's not necessary. Therefore, I'm going to delete this one. And then let's look at the else. The else will be d greater than or equal to 2, right? So in this case, first we can consider this I plus dp I plus 1 and I plus d minus 1. So this meaning is meaningful because I plus 1 is less than or equal to I plus d minus 1, right? If you look at this equality, so I and I cancels, and then you put the negative 1 in the right to the left, you get a 2 less than or equal to d. So it's essentially this one, right? So now what we do is this. If si equals si plus d, the two ends, and also if in the intermediate part, not as dp I plus d minus 1, if this is the palindrome, then we can extend to I to the left and to I plus d to the right. Then we know that dp I I plus d should also be 1, right? So then let's see. This is the s this is the same. Then dpi, if this guy dp I plus 1 I plus d minus 1, then we should set this I plus d to be 1, right? So then this will be the full information. But now we want to find each index I. So what's the longest possible palindrome substring from there? So we can initialize a result, and then we get a 1 times n. So here, because it's at least 1, right? So then what we do, so we want to find the largest j for each I, such that dpij is 1. So for I in range m. So for j in range, so I'm going to iterate from the right to left. So I minus 1, negative 1, right? And then if dp ij is 1, right? Then I'm going to set the result I to be j minus I and plus 1. Then I just find 1 for this I. Then we find this for each I. Then we're going to return the result. So this will be the coding for getting this piece of information by hint 2. So now let me quickly check the code if it's right. So we have this this one, n, right? Then d. So in this range, if d equals 0, so we set this to be 1, right? And then if d equals 1, so we compare I and I plus d. So dp I plus d is 1. Otherwise, we consider I and I plus d again. So then if the middle, so this one is palindrome, then we've set dp I and I plus d to be 1, right? Then this is the 1 to n for I range. So n minus 1, I minus 1, negative 1. So if dpij, so result will be, yeah. I guess we got this part. So now let's test this function. So here, let me use this as like ABA. Let's write AA, right? Let's print self hyper function. So let's see this S. So for this A, if you towards the right, you can up to ABA, right? The length is 3. For the b, you can only have itself, that's the 1. For this at index 2, you can move towards next a, you get aa, and it's 2, and then this is the 1, right? So now let's look at this. So for this s, if we can, for each index, we can extend to left, and what's the longest? So let me write a t, right? So that's t like this. So if we want to write to the left, because we need to do some reversions. So let's see, -1, and then -1. So now let's print out this. Let's write as t. So for this one, if you go to the left, and just the a itself ending at here, right? It's the 1. For this b, you can only have this b itself, is the 1. For this a, if you want to move towards the left, you get aba, 3. And for the last a, you can only have the 2 a's, that is 2. This is the right? So now we have this. So basically, let's do the problem logic. So we get the information of s. So this is self helper, so s. Then for this one, let's call it infer s. So the infer t. This will be this one, right? So let's see, hyper, right? So basically, for each s, for each index towards the right, I know the longest palindrome. For this t ending at an index, I know the longest possible palindromic string to extend to the left. So now let's look at the problem logic. So for doing the problem, let me first get the m and n. So it's the length of s and length of t, right? So we are going to use this hint, but make some variant. So what we want to do is this. I'm going to use this dp. So it's 0 times m plus 1 for I in range m plus 1. So the interpretation will be the following. So the dp I j. So basically, so we use let's see, maximum length from using length I of s. So starting from length I of s, and ending at length j of t. So notice that I'm using starting at length. So here the length and the index is different by 1. So this is very convenient, because if you look at the last row in this dp, it corresponds to a length m, right? So it means an empty, right? Or you start from empty. So in this case, so basically we can set dpm. So you can understand this as index if you like, but it's empty, right? Or so this will be 0 plus info t, right? Because we just consider the information corresponding to t, because we choose s as empty. So this is the one part. So similarly, also we can set the for starting from t at the length 0 is nothing, right? In this case, basically for I in range m. So dp I 0, right? And then it will be info s I, right? So you can print out this and dp. Let's use the this one maybe for that just invalid. I got a comma, print d. Let's see. Right, but in this case you have 1 and 0 and 1, but let's use case 2. That would be better, right? So for case 2, you know, if you choose s to be empty, then you can look at this last row. So if t is length 1, so you get d just length 1, you get 1. If t is length 2, you get also 1, and t is length 3, you also get 1. But this may not be best. Let's look at case 3. So this is much better, right? So if b is you look at the second one. So if you t is length 1, you have extend to the left, you get 1. And then t is length 2, extend to the left, you get 2. 3, you get 3's to the left, and 4, you get 4's. It means that what we wrote is right. So now let's look at the dp update rule. So now let's do this for I in range. So I'm going to from m, because I have set m, because for s I want to from backwards, right? m minus 1 and negative 1, negative 1. Well, for g we are going to use range, so from 1 up to n, right? So now let's look at this. So here we are going to consider si, right? If it does not equal to g minus 1, notice that I'm going to consider length, right? So that's why you write g minus 1. But here, because I is already from m minus 1 to 0, so we just write si. So there's some asymmetry because the concatenation is left and right, right? So then the dpij will be the following. So it will be the max of info s. So because they are not the same, so I want to check from index I, then to the left, to the right, what's the longest possible, or info t from g minus 1 to the this s is to the right and the t is to the left, what's the longest possible. Otherwise, if they are the same, so there are more possibilities. So ij, it will be max of info si, right? So from I towards the right, and the info t and g minus 1 from the the left. Or because they are the same, then we want to have the 2, right? So we want to see if we have this dp I plus 1 starting from s and from index 1 I plus 1, and the j ending at, because here its length is g minus 1, so here we get g minus, so here we write g minus 1. So then this will be the general update rule. So what we want to return actually is the largest possible dpij's. So in this way, in this regard, we can do this. So we can, because here we have dpm, so we can initialize our result to be the max of dpm. And then each time we are going to update the result to be max the previous state and dpi naught. Actually, this is just the info s. Actually, you can set as max dp info s and info t. And here, once you set this dpi, you can do result equals max result and dpij. And this way, you are going to get the final result. Just return the result. So this will be the full coding. It's actually very detailed. Now let me first run it, and then we can print out some information and for the digest. It passes the 5 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So here there are several comments. First, this hyperfunction to find the longest palindromic substring. So actually, this way of writing is very logically sound. I saw some of the solutions for finding palindromic strings of 2 strings s and t, or just s. So they do what they do is to find the longest common substring of s and s inverse, then adds the length. So this is not correct. So you can see my previous video to find some counter examples, right? So this way of writing here, our method is rigorous and sound. So this is the first comment. Actually, this problem itself can be a say leetcode problem or interview problem. So this is the one comment. The second comment is that when I write this code, so here this one, So once you write one hyperfunction, and then you can use this trick to get the information for t. Or otherwise, you can write another function, but reverse the order for the hyper to get this piece of information. You need to digest this part. This needs some thought. And then I write using tabulation again to write, but here I'm using length. But also you need to notice that because of the concatenation, S is in front and T is in next. So here you see some asymmetry, right? So here I'm checking S and I, but T and J minus 1, right? So with that said, I guess this is the second comment. So the third comment is that we have a large dynamic programming playlist. So in our channel, you're welcome to check out the problem to practice. I guess for this problem, indeed, it's qualified as hard, right? As you can see our length of this video. So with that said, I guess that's it. Thank you for watching.